Start yonder camera.
Start yonder camera. So your answer to 3A, because if that's wrong, everything's going to be wrong, should be around 5,000.
Yippee.
On 3C, you need two answers, the UG and the kinetic energy. Do not just write down numbers and expect that I know what those are. Make sure you specify which is the UG and which is the kinetic energy. On D, you need two answers. You need a value for energy and you need a velocity. Make sure that you have both of those. On number 4, you'll see that this is actually changes, but on number 4, here's what your graph should look like. Because when you compress like a spring or pull a bow back, it actually changes as a function of distance. That's why I said it's the average force. So this is what this graph should look like. So your answer to 4B, because basically what you did is you pulled this back, you did work. You let go of it. Mother Nature doesn't like potential energy. She goes, oh, screw this, I want kinetic energy. So then she takes all of that energy stored in the bow and changes that into the kinetic energy of the arrow.
No leg.
So that answer on 4B should be around
I knew it
40.
was my leg.
Yes.
Okay? And then, because that's going to drive everything else. On 5D, so let me give you some hints. So the whole idea of number 5 is that, and this is true of all forms of energy. So if you throw something down from the top, you have UG and some kinetic energy initial. Well, that's going to add up to the final kinetic energy. So this is what I showed you. If you go, oh, mgh plus 1/2 mv naught squared equals 1/2 mv squared, then your masses all cancel out, and then you multiply by 2, and you get that equation. Okay? So that equation just comes from the idea of energy. Now, because of the fact that this is a scalar quantity, okay, it doesn't make any difference which direction I throw that ball. I could throw it at a 45-degree angle, I could throw it down, I could throw it up. As long as I throw it from the same height and I throw it with the same velocity, it's going to land with the same overall velocity. So, now, on number 5, if you think this through, what you're told is that the ball lands going 7.5 meters per second. So you're going to throw it from up here. So obviously, what does your answer have to be less than?
7.
Yeah, your answer has to be less than 7.5. You're not going to throw it down and then have it slow down as it approaches the earth, which would be cool, don't get me wrong, okay? But that's not what you got. All right. On number 6 with the rocket, because that all hinges off of each other, your answer to 6A and a whole bunch of other things on number 6, every answer on number 6 should start with a 1.
That's good.
And should the second digit for all of those be 7s?
No.
No. Wait, which
One
one?
of them is an
I got 4.
Wait, does that round up? I wish I had my calculator so I could.
Did you guys get,
should,
like,
well, it should be
100?
18.7 meters.
No.
Is what I got.
4, 5.
Every
I got
answer on
44.
number 6 starts with
No,
a
18.7 meters per second.
1. And a
Let me
lot
see
of
it.
them should be
Let me
something
see
times
it.
10 to the third or close to your current age.
I may have done
Because I
that.
was confused, like, because I felt like something was wrong.
So on number 6, every answer starts with a 1, and it's either 10 to the third or close to your age.
Shoot. You just times the force times the distance.
Did I not do that?
Now, let's talk about on the,
I think it's just times 10 times the gravity.
like on the-
force.
question 28.
I'm doing it though.
So this is where you've got to use that equation. And I know that isn't on your equation sheet.
What
If
height
you
does
ever
he
need
have
it
that
on the
much
test
potential
or
energy?
something, I'll give this to you. So what's happening on question number 28 is this. Here's this wrecking ball, and it's 5 meters long, which is fairly long. I mean, that would be like twice the height of the ceiling. And you got a 30-degree angle with the vertical, so that angle in there is 30 degrees. And the ball is released and swings down. What's the ball speed at its lowest point? So
3.6
here's
meters
what I want. There's a couple of things that I want you to get out of this problem. Whether you lift this thing, like here's your wrecking ball. So whether if you lift it up like this to a certain height on an arc, or if you lift it over here, the change in the energy is the same. Because of the fact that if you look at, because this is a scalar quantity, whether I lift it up here or I swing it out here, it has the same amount of potential energy, so it's going to have the same amount of kinetic energy when it gets here. It's either, if you just drop it, all that kinetic energy is straight down, that's the direction of your velocity. If it swings like this, all that velocity is going horizontal. But it's the same kinetic energy. So what you have to do is find that height, and that's where that equation comes from, where you have height. What's wrong?
I don't know what number that is. Do you,
Looks like a 1.102.
I think it's supposed to be a .102.
yeah, I wrote .102 over there, but then
Because that's what I got.
I also got
I wrote it
.102.
down there. I just added it.
I feel pretty good about this assignment. We're either all super stupid or we did pretty
I
good.
don't know.
Anyway,
This is getting
and then you need
I got
that same
53.
thing on 20. So your answer to number 20 should be something times 10 to the 4th.
I did it.
Is it on that joules?
Huh?
That's joules, right?
That's in joules.
Okay.
On 28, this is out of the book, that problem, the whole key to that is that it's going to have kinetic energy and potential energy. So on 28, because if that's wrong, it's going to be wrong. Your answer to 28A should be in the mid-20s. Now, on 32, there's a couple of different ways you can work 32. So, notice on 32A it says, can the car make it to the top of the hill by coasting? Give a justification for that. Do not just say yes or no. So, here's the hill, and that's 5 meters above, and then it's going to come down here like this, and then that's going to end up 5 meters down here. Okay? So, here's the story. Basically, this is, you have a certain amount of kinetic energy here, which you can find because of the fact that you have the mass and the velocity. So you can figure out how much kinetic energy that it has. So one option, there's various options that you can do. The simplest is to say, well, let's assume that all of that kinetic energy changes into potential energy. And how high could the car go? So then you can go, well, the kinetic energy of the car equals the potential energy at the top of the hill. Oh, okay. So then you go, okay, that's 1/2 mv squared equals mgh. And then the masses cancel out, and then you get 1/2 v squared divided by g equals h. So if you solve for that height, when you convert all of it into energy, if that value is greater than or equal to 5 meters, it will make it up to the top of the hill. If you solve for h and that's less than 5 meters, it's not going to make it. So, when you get to 32b, you want to, if it does, which it can by the way, what is the car's speed after coasting down the other side? And again, this is just conservation of energy. So you have a certain amount of kinetic energy here, which would match the same amount of kinetic energy when it got back to that same point, but then it's going to gain some UG as it goes down the hill. So, if all goes well on 32, that answer to 32B should be something close to in the mid-teens. Okay?
I'm good with that.
Anything else?
Close to Gapshan's age.
Yes.
Don't get judgy.
I'm not being judgy.
Yes,
Just say I'm in the
that's
same
being
class as
judgy.
you right now.
Okay.
Yeah.
Oh, yeah.
You're also
child
an-
prodigy.
Baby. This is a baby, little boy.
But
I
is
mean,
he,
oh,
but
yeah,
is
I
he a
think-
bad boy?
Oh.
Ooh.
What you gonna do?
Not as bad as Cohen.
That's valid. No one is. Okay, are we good? Going once, going
Cohen's
twice.
the baddest of boys.
Sold. So shut down yonder camera.